Alright, for our second video tonight, we're going to be finding vertex and graphing in vertex form. So the finding vertex should be a review. So here we have a quadratic equation given to us in standard form. Remember, standard form is y equals ax squared plus bx plus c. So in here, the 2 would be my a, the 8 is my b, and the 7 is my c. We have to remember our variables and match them up. Alright, to find the vertex in the standard form, you need to use the formula x equals negative b over 2a. This will give us our x value for the x coordinate for our vertex. So in this case, it would be negative 8 all over 2 times 2, which is negative 8 divided by 4, which equals negative 2. So that is the x value of our vertex. So to find the y value, you are going to substitute the x into the equation and get the y. Okay, so like I said, most of this should be a review. So to find y, I'm going to substitute x. So it was negative 2 squared plus 8 times negative 2 plus 7. So if we plug this into our calculator, we get that y equals negative 1. So that tells me that my vertex is at negative 2, negative 1. I know that the graph opens up in a positive direction here because of the 2 is positive. I know it's going to be skinnier because the a value is greater than 1. So I know it's going to look like this. Open up and going to open up, and my vertex will be at negative 2, negative 1. Okay, the second example I'm going to look at is x minus 2 times x plus 6. Now this is in factored form, and I could go ahead and I could FOIL this back out and get it in standard form like example 1, but since we've already done an example like that, I'm going to leave it in factored form, and we're going to find the vertex by using the average method. So I know that my x-intercepts here, I could solve for those in factored form. So I'm going to get that x equals 2. I'd add 2 to both sides here, and then I would subtract 6 from both sides, and I guess x equals negative 6. So that tells me that my intercepts are going to be at x equals 2 and x equals negative 6. Well, I know my vertex will always be in the middle of these, so I can just find the average of the distance between here, and that will be my vertex. So if I take 2 plus negative 6 and then divide that by 2, I get negative 4 over 2, which gives me negative 2. So that is going to be my x value of the vertex. It's the middle distance between the two endpoints. Alright, so now I have my x value, and just like in the factored form, when we have the x value of the vertex to find the y value, you substitute it back into the equation. So I'm going to substitute negative 2 minus 2 times negative 2 plus 6, and I get y equals negative 4 times positive 4, so y equals negative 16. So that tells me that for this quadratic, my vertex is going to be at negative 2, negative 16. I know that it's going to open up again because my a value here is positive 1. So we'll look at the graph. That will be negative 2, and then way down here and open up this way. Okay, the third example we're going to do when finding vertex is actually looking at a quadratic in vertex form. Like, remember what we said that in class today, that y equals a times x minus h, quantity squared plus k. That's my vertex form. hk is my vertex. So from this graph, from this form of the equation, I can tell that my vertex is going to be at negative 1. Remember, h is a liar. He's positive in the equation, so that means he's negative. K tells the truth is minus 2. And I'm going to open down here because of this negative. So if I wanted to kind of quick sketch, negative 1, negative 2, and I'm going to open down. Okay, now we're going to look at graphing in Vertex form. And just like I said in class today, graphing in Vertex form is a lot easier than graphing in the standard form. Because in standard form, you have to either factor it to find your x-intercepts, you have to find the vertex by using x equals negative b over 2a. But in Vertex form, it gives us a starting point. It gives us our vertex. So again, I know that the quadratic, the Vertex form is y equals a x minus h quantity squared plus k. Remember, hk is my vertex and h is a liar. So if I look at here, I know that my vertex is going to be negative 1 comma negative 2. So that gives me a starting point to graph. So if I want to draw my graph here, kind of just a rough graph here, and I know I'm going to start at negative 1, negative 2. Alright, so I'm going to draw the graph, and to do that we're going to do just a quick table of values. So in my table of values, I would start with, put my vertex in the middle and look at 2 points to both sides. So if I'm at negative 1, I'm going to look to the left at negative 2 and negative 3, and then to the right at 0 and 1. And then you just plug in these values into the your original equation and get your y value. So if I plugged in negative 3 into the original equation, I get that y is equal to 2. If I plug in negative 2, let's just do this real quick. Negative 2 plus 1 is negative 1. Negative 1 squared is 1, minus 2 would be negative 1. If I put 0 in there, 0 plus 1 is 1 squared, minus 1 is negative 1. And then 1 plus 1 squared is 2, square of that is 4, 4 minus 2 is 2. So now I have some points. I can graph those. So at negative 3, I'm at positive 2. At negative 2, I'm at negative 1. At 0, I'm at negative 1. And at 1, I'm at 2. So I have a rough little sketch here of my graph. Okay, our last example for tonight is graphing again in vertex form. So I'm given the equation y equals negative 1/4 times x minus 2 quantity squared minus 1. So again, guys, remember our vertex form, y equals a x minus h quantity squared plus k. hk is my vertex, and then remember a tells me the direction of the opening and the width. So I notice that a is a fraction. Remember, if I'm a fraction less than 1, I'm going to be wider than the parent function, and since I'm negative, I'm going to open down. So again, looking at the equation, I can get my vertex. I can see in here that my h value is looks like negative 2, but he's a liar, so it's going to be positive 2, and then k tells the truth, it's negative 1. So again, I can do a rough sketch here. And then I know I'm starting at 2, negative 1 is going to be my vertex. So again, we're going to create a table of values. We'll have x and y. We'll put our vertex in the middle, 2, negative 1. So I'm going to look at 1 and 0, and then 3 and 4. So if I plug 0 into the equation, I get that my y value is negative 2. If I plug 1 into the equation, I get negative 1.25. If I plug 3 into the equation, I get a negative 1.25. And if I plug 4 into the equation, I get negative 2. So we can sketch this. So at 0, I'm negative 2. Oh, sorry, graph that one. At 0, I'm negative 2. At 1, I'm negative 1 1/4. At 3, I'm going to be 1 1/4. And then at 4, I'm at negative 2. Now my graph isn't perfect because it's not to scale, but we're going to have a wider graph opening that way. Okay, so make sure you bring your notes tomorrow to class, any questions you have, and have a good night.